Hello and welcome back. In this video we continue our discussion on motion with the constant acceleration. Remember, for an object moving with the constant velocity in one dimension, the displacement is its velocity times time of travel. For an object with the constant acceleration in one dimension, the displacement for a period of time t can be derived as xa minus xb equals v0x plus half ax t square, and velocity at any instant can be derived as vtx equals v0x plus ax t. In this video we discuss motion in two dimensions. A typical example of two-dimensional motion is a projectile, for example punting of a football. This is two-dimensional motion with the constant acceleration of minus g meter per second square in the j direction. In this example, the player kicks the ball and provides an impulsive force to the ball so that it flies off the ground. Let us assume that the ball is kicked with an initial velocity of 20 meters per second at an inclination of 30 degrees to the horizontal. In this video, we analyze this motion to predict instantaneous velocity and displacement of ball at any time t, the maximum height, the range, and the time of flight of the ball. Using trigonometric relations, we can represent this initial velocity vector as 20 cos 30i plus 20 sin 30j meters per second, or 17.3i plus 10j meters per second. Now let us consider the forces acting on the ball once its motion begins. The moment the ball begins motion, it is acted upon only by the force due to gravity, which is the weight of the ball acting in minus j direction. This is a simplified assumption. Actually, motion of the ball is affected by other forces such as resistance of air. Let us assume that these forces are negligibly small in this analysis. Now we shall discuss about equations that governs this motion. The fundamental law that describes motion of a particle is Newton's second law, which states that force is the product of mass and acceleration, or F equals ma, where F is the net force acting on the body and m is the mass and a is the resulting acceleration. In this case, the force acting on the body is minus mg, or the weight of the body in the downward direction. Therefore, we can equate equation 1 and 2 so that we get the acceleration vector as 0i minus gj, from which we get two equations, ax equals 0, equation 4, and ay equals minus g as equation 5. Integrating equation 4, we get x component of velocity vector as vx as constant, since the initial value of x component of velocity vector is 17.3 meters per second in I direction. This constant will be equal to this value. Displacement in x direction will be this velocity component times time t. For motion in y direction, integrating equation 5, we get y component of velocity vector in any given time as vty equals v0y minus gt. Integration of this equation will lead to displacement in y direction as yb minus ya equals v0yt minus half gt square. Combining x and y components, we can express the velocity vector and displacement of the projectile for a given instant of time t as equation A and B. Now, for a football kicked with initial velocity 20 meters per second at an angle of 30 degrees with x-axis, calculate the velocity and displacement of ball in time t equals 1 second. Now, substituting t equals 1 in the previous equation A and B, we get the velocity vector as 17.32i plus 0.2j meters per second, and the displacement vector as 17.32i plus 5.1j meters. In the next video, we discuss the time of flight of the ball and range of kick. Thank you for listening.